Welcome. You know that feeling, right? You spent hours, maybe even days debugging an NLP model, and it turns out the whole problem was buried in your data prep? The real challenge in NLP often isn't the big, complex theory, it's these tiny, hidden details. Today, we're going to uncover two of those traps that can absolutely make or break your entire project. So let's dive right in. Look, it's one thing to understand the high-level concept of, say, a token classification model. But it's a completely different beast to actually get your data prepped and shaped in just the right way so the model can even start training. That's where the real work, and honestly the real headaches, often begin.
And that's exactly what we're going to focus on. We are pulling back the curtain on two extremely common, but so often overlooked, gotchas in data preparation. Getting these two things right is pretty much the difference between a model that works and one that just keeps throwing errors.
Our first challenge is a total classic. It's a headache you'll run into in any task where you're labeling individual words, like in named entity recognition. It's called the token alignment problem. And trust me, it trips up just about everyone at some point.
Okay, so here's the heart of the issue. You start out with your data all perfectly lined up. You have a list of words, and for each and every word you have a nice corresponding label. It's perfect. But the second you hand this beautiful data over to a modern tokenizer, that perfect alignment can get completely shattered.
So check this out. Imagine in our original dataset, we have the word embeddings and its label is B-per, which could stand for, say, the beginning of a person entity. It's simple, it's clean, it's a one-to-one match. This is our perfect starting point.
But then, look what happens. A powerful tokenizer, maybe one from a model like BERT, doesn't just see embeddings as a single thing. To handle a massive vocabulary, it's smart, and it breaks words down into smaller subwords or word pieces. And just like that, our single word has become 4 separate tokens. And right there, that's the problem. We now have 4 tokens, but we still only have that one single label from the beginning. If you try to feed this mismatch to your model, it's just going to crash. The inputs in the labels absolutely must have the same length. So what's the fix?
Well, the solution is this really clever process called label alignment. The whole goal here is to create a new list of labels that is the exact same length as our new list of tokens, and we have to be really smart about how we label those extra subtokens.
And the standard way to do this is actually pretty simple but brilliant. We take our original label, the B-per, and we assign it to the very first subtoken. Then, for all the other subtokens that came from that same word, we assign a special label, -100. This is a magic number that tells the model's loss function, hey, just completely ignore these tokens when you're training. This fixes the length mismatch, but it also makes sure we only calculate our loss on the meaningful start of each word. Problem solved.
All right, that's trap number 1, diffused. Now let's get into a second challenge. This one comes up in a different but just as popular type of model, the sequence-to-sequence model.
Think about tasks like machine translation, where the input is a sentence in English and the output is a sentence in French. Or think about text summarization, where the input is a massive article and the output is just a few sentences. The model isn't just classifying something anymore. It has to generate a whole new sequence of text, and this creates a totally unique preprocessing puzzle.
So here's the puzzle, right? You've got 2 different pieces of text, the source text that goes into the encoder and the target text that the decoder has to learn. You can't just toss them both into the tokenizer the same way and hope for the best. You have to treat them differently. The secret here, the real trick, lies in using what's called a special context manager. Think of it like a switch you flip to tell the tokenizer, hey, pay attention, the text I'm about to give you isn't a normal input. This is a target label. You need to treat it differently. So the whole workflow looks like this. First, you tokenize your input text just like you normally would. No surprises there. Then you open up this special context manager, and inside that block of code, you tokenize your target text. This makes sure that both sides get converted into numbers correctly, but with the very distinct settings that are needed for an input versus a target. Oh yeah, it changes things in a big way. The complexity here actually moves from the preprocessing step right into the training loop itself. See, since the model's main job is to generate text, we can't just check a simple classification output to see if it's doing well. We need a totally different way to evaluate it.
And that's exactly where this generate method comes into play. Instead of just getting a simple loss value, this function actually makes the model produce a brand new sequence of text,
just like it would if it were being used in the real world. This is so different from a standard training step that it often means you have to write a custom training loop just to handle the evaluation correctly.
Whew. Okay, so we've just walked through two of the biggest, sneakiest traps in NLP data prep. Let's just quickly recap the key takeaways you really need to remember for your own projects.
Let's boil this all down. For token classification, it's simple. After you tokenize, you must realign your labels using that -100 mask. For sequence-to-sequence models, always process your target text inside that special context manager. And finally, be prepared to build a training loop that uses the generate method for evaluation, because that's how you'll know if it's actually working.
You see, mastering advanced NLP is really a journey of uncovering and understanding these critical, practical details. They are truly the difference between a model that works and one that just keeps throwing errors. The good news is you're now 2 huge steps ahead on that journey. So keep digging, keep questioning your data, and you'll get there.